So just like we can write generic classes, we can also write generic methods. And a generic method also uses a formal type parameter, but instead of that type parameter applying to the whole class, it applies just to that particular method only. So it's local to that particular method. And we can put generic methods like this inside of our normal non-generic classes. So you can have a class that does not use generics, and you can put a generic method inside of it. And the type parameter is again local to that method only. So you're defining, it's the same way you're defining a formal type parameter for the class, like we just saw, but you're just doing it only at the scope of a particular method rather than throughout an entire class. This is what the method header might look like for a generic method. So you'll have public, it can be static or not. Then next you put the generic type. So inside your angle brackets there, you define the generic type. You might call it again T. Then after that is the return type. So this could be void, or in this case, it's T. I'm going to return an element of the generic type. Now be careful here, this can look a little strange because it looks like it's sort of duplicated there, but just be careful. The generic type declaration comes first, then the return type comes next. Okay, and of course this could also be void or int. It can be any return type just like any other normal method. It just, in this example, it's also returning an element of that generic type. And then your method, and then you can also use that generic type again as a return type, or you could use it as a parameter. You could take in an array of things, or a single item, or whatever it is. Okay, so this is what the method header looks like. For the most part, it's just like any other method header. The big difference is we've added a generic type. We've added this angle bracket T. And then now that we've declared that type, we can use T throughout our method, including in the rest of the method header. Now, how you'd invoke this method, this was a static method, right? So it's going to be invoked through the name of a class. So you'd invoke it as my class dot, and then inside of angle brackets, you put the string you want to use. I'm sorry, the type you want to use. So my class dot angle brackets string, do something, sending in the my string array, or my class dot angle brackets integer, do something, sending in the integer array. Or oftentimes the compiler will actually let you omit this completely and will use what's called type inference to figure it out. So if you invoke my class that do something and send in an array of strings, it's going to figure out that what belongs here is a string. So oftentimes you can just omit the type and it'll figure it out for you using type inference. And if it can't, then you'll get a compiler error and you'll just have to put the type in. Okay, but this is how you'd invoke that method. So let's take a look at what this looks like. And to look at this example, we're going to write some array utility methods. So we're going to write methods to create a list of duplicate numbers that appear in an array. Okay, so if we look at array utilities here, so here we have an integer of arrays. This is my little tester program. I'm just creating an array of 100 integers, and I'm going to fill it up. In my fill array here, I'm just generating random numbers between 0 and 499, and I'm just filling up that array with random numbers. Okay, and then what I'm going to do, just comment this part out, is just print it out for now. Okay, so here I'm just filling up an array of 100 random numbers between 0 and 499. Okay, now there might be some duplicates in this array, right? Because I'm just randomly generating the numbers. There's no test there to make sure that they're unique numbers, so there definitely could be some duplicates in there. So a reasonable thing I might want to do is find out if there's any duplicates. And let's say we want to create an array list that stores one copy of every duplicate item. So if the number 14 is in there 5 times, I'd want to put the number 14 on my list so that I'm aware it's a duplicate. Okay, so we're first going to just write this method without generics. Okay, so we're just going to write a pretty simple method here. So this is what our method header might look like. So we're just saying find the duplicate integers. We're passing in an integer array, and we're going to return an array list that holds integers. Okay, so this is what it's going to look like. So what I can do is I can just create a new array list. I'll just call it the duplicates. I'll call it the duplicates. And again, on the right-hand side here, I can either use just the angle brackets or I can use the angle brackets with integer. Either one's allowed, but I always need to use those caret brackets. Okay, so that's going to be my list of duplicates. And then I'm just going to cycle through my array. And for every element in the array, I'm going to search the rest of the array to see if the number appears in there again. So I'm going to have a nested loop here where my j position is going to start at I plus 1 and go up to numbers.length. And I'm going to say, well, if numbers at position I is equal to, and these are just integers, so I can compare them with the double equal sign, numbers at j. Then I'm going to go ahead and add that number to my duplicates array list. Now I'm also going to add another check here because I said I only want to add a duplicate one time, so I'm also going to make sure that the duplicates list does not already contain that number. So if it doesn't contain it, I'll go ahead and add it. Okay, so that's my nested list. That's going to figure out if I have any duplicates. And then at the end of my loops, I can just return my duplicates. Okay, so that's a pretty straightforward method. Let's now invoke it here. Okay, so I'm just going to invoke that method with my numbers array and print out the duplicates. So there's my array, and I had 4 duplicates in there, 93, 71, 36, and 52. Of course, this is a randomly generated numbers in my array, so if I run it again, I'm going to get different results. Here I had 2 duplicates, okay, 15 and 42. Okay, oh, just 1 duplicate there. Okay, so that's a pretty straightforward method. Now let's say I want to do the same thing but with string. So here I have a string array, so it holds 100 strings, and I have a method to fill it up. So to fill up my array, I am just generating random characters. Characters have a corresponding integer value, and the character A starts at 97, so I can randomly generate a number and add it to 97. I'm just going to randomly generate letters of the first 10 because I want to make sure to get some duplicates. And so this code here is randomly generating words of length 3 using only the first 10 letters. Okay, so you can take a look at that code, make sure it makes sense. But again, I'm just sort of creating essentially nonsense words of length 3, but I'm only using the first 10 letters because I want to make sure I get some duplicates. Okay, so let's fill that up and print it out. So this is, you can see now what my array looks like. It's just 3-letter, combinations of 3-letter characters. Obviously, these aren't all real words. Most of them are not real words. But what I want to know is, hey, are there any duplicates in there? Now, of course, I can't invoke my find duplicate integers method, right? Because that takes an integer array and I have a string array. And I don't want to get back an array list of integers. I want to get back an array list of strings. So I basically need to write the code again, right? So, okay, let's do this for strings. Now, I should start to notice that this code I'm typing is eerily familiar. Yeah, I definitely already typed that loop. This looks familiar. All this looks familiar. Now this part is going to have one small difference, right? Because I'm just going to say if words at I, because this is a string, I'm going to use the dot equals method instead of the equal sign. But technically I could have used, this should be words. I could have used the equals method up here too, right? Because these are capital I integers, so I technically could have used that there too. But other than that, and other than the name of my arrays here, this code is essentially the exact same thing, right? I'm duplicating what I just did above, right? Okay, so now now I can invoke my finding duplicates of my strings. So here I'm just going to invoke array utilities.find duplicates, passing in my words array, and print out my results. And there are my duplicate words. Okay. And there you go. So both of these methods work just fine, but it seems pretty ridiculous that I had to write 2 different methods, right? I'm doing the exact same thing. I'm cycling through the array one time and then having a nested loop to cycle through the array again, looking for matches. And I'm putting those matches into an array list. And that's what I want to do. I'm doing the same thing twice. I'm just doing it for 2 different data types. So this is the perfect use of generics. So what we're going to do now is we're going to write a third method that uses generics. And this generic method now can be applied to any type. So instead of having to write one method for integers and one method for strings, and let's say I had an employee that I wanted to find any duplicate employees on my list, I don't want to have to write a third method because, again, it's the same logic. It's the same approach I'm using. I don't want to write the code again. I want to just write it one time and be able to invoke it with any type, and that's what generics is for. So let's write a generic version of this method. So the method's still going to be public and static, but now I'm going to declare a generic type for the method. So I'm going to put my caret bracket T. Okay, and my return type is going to be an array list that holds elements of type T. So if I invoke this method with an integer, as the the type, then my return type is going to be an array list of integers. If I invoke this method with string as the type, then my return list is going to be an array list of strings. Okay, and I'm just going to call this find duplicates, and I'm going to take in as a parameter an array of type t. Okay, so this is now going to be, means I can pass in an array of integers or an array of strings or an array of employees or any type I want, and that is going to become the generic type for the method. Now, other than that, I basically can just do the same code, only I'm using type t here instead of integer or string. Okay, so I'm declaring my array list to hold type t, then I'm cycling through my array using a nested loop. Now, what is going to be the type of the object at array position I? Well, it's going to be type t. But we know that we're okay to invoke equals on it because equals is inherited from the object class. So every class has an equals method, right? So we're guaranteed that that code is going to work. So no matter what type it is, I know it's going to have an equals method because every class has an equals method. Because at the very least, it has the one inherited from object, even if it hasn't been overwritten. Okay, overridden. So I can invoke equals, and then here I'm just, checking my duplicate, I'm adding it, and I can return it. So this is my generic version of the method. And again, the big difference here is I've just declared this generic type as part of my method header, and I can then use that type throughout the method itself. So now to invoke this, we can go back, and let's instead just say, so this, I'll just comment this out. This is the invoking, actually we'll leave them both in so you can just be convinced that it gives you the same result. And what we'll do is we'll just call the non-generic version first, and then we'll just reassign it to the generic version. So the generic version is just called find duplicates. And here you'll see that I actually have used type inference to figure out that integer is the generic type. So I didn't have to put integer, but the fact that I'm sending in an integer array, Java was able to figure out that that's the generic type that should be used. Now, when I'm invoking it for strings, what I'll do is I'll show you what it looks like with the type specified. So here, again, same method, find duplicates, but I can call it with a string array, and it's going to give me the appropriate return type, an array list of strings. Okay, an array list of integers there, an array list of strings here. If I wanted to put the type in, I can do that. It would look like this. So this one explicitly defines the actual type being passed in, and that one uses type inference. Both of them are allowed in this case. Okay, and if we run this, you'll see that you'll get the same results. Oops. Why did I get two different results here? That's strange. I'm missing something. Let me pause this a sec. I'm missing something. Okay, sorry about that. I did have a bug back in my original non-generic find duplicate integers method. I had a total brain freeze there, and of course you can't compare capital I integers with the double equal sign. That's only for ints. So what we could do if we want to use the double equal sign is we can invoke the int value to compare it. That allows us to compare the primitive value, or of course if we just want to be consistent and use the comparison we always use for objects, we can just compare with equals. So sorry about that mistake I had in there earlier. Also, I should have noticed that there were way too few duplicates being found for the numbers I had in there. So sorry I didn't pick up on that. But anyhow, back to the generic part, which is the focus of this video to begin with. That you'll now see that the two methods return the same duplicates, the same list of duplicates. Okay, so again, the point of this is to show you that instead of having to write the different methods that do the same thing for different data types, we can write one method that uses generics, right, and declares the generic type for the method only. So this isn't a generic class, right? This is just a regular class. There's no generic type in the class header, but this method itself is generic. So this generic type is visible and applies only to this particular method. Okay, we've also looked at the two different ways you can invoke this method. So one is just with type inference, where I'm passing in an integer array. So Java uses type inference to figure out that the generic type is integer, and that means we're also returning the return value is going to be an array list that holds integers. Or here I've explicitly passed in the generic type is going to be of type string. And again, that means I'm passing in a string array as the parameter, and I'm getting back an array list that holds string as the return type. Now, if I were to try to pass in my integer array in here, I'd get a compiler error because it would say, you're trying to pass in, you're telling me that string is the generic type, and then you're giving me an integer array, and that doesn't work. Similarly, if I were to try to, sorry, come on. My Eclipse is frozen now. Similarly, if I were to declare the generic type to be string and try to then store the return type in my array list that holds integers, it's also going to give me a compiler error because it's going to say, hey, I'm going to return to you an array list that holds string, and you're trying to put it into an array list that holds integers, and those are different types. So we have that compile time type checking just like we did with generic classes.